Hello everyone, I'm going to introduce our paper about adaptive SVRG. In this paper, we consider finite sum optimization problem where fx is convex and L smooth, Cx is proper, lower semi-continuous and convex. There are many applications in machine learning for this finite sum problem. For example, empirical square laws and empirical logistic laws. Several methods have been developed for solving this problem, for example, PG and APG, but when the sample size is large, it may lead to expensive computation and even become prohibited. Another method is SVRG, but it converges slowly because of the variance of gradient. Then SVRG was proposed for solving that finite sum problem. On the theoretical side, it can achieve linear convergence when the problem satisfies quadratic error bound. Here I want to mention that one example satisfying quadratic error bound is strongly convex function. But SVRG must depend on the unknown parameter C, and this parameter is difficult to estimate. In this paper, we will study a more general error bound called the lderian error bound, or HEB for short, which here the theta is between 0 and 1/2. First, we propose a SVRG algorithm on the HEB. The structure is same as a standard SVRG, but it increases the number of inner loop T by times a factor 2 to 1 minus 2 theta. In this case, we assume the parameter C is given. We can provide the iteration complexity of SVRG HEB. From the convergence result, we can see that the number of iterations for each inner loop depends on the unknown parameter C in HEB condition. In another word, a small value of T1 may not guarantee the SVRG HEB converges. So we want to develop adaptive SVRG for searching the unknown parameter. We first consider the case of the theta between 0 and 1/2. The proposed algorithm uses the restarting trick, that is, restarts SVRG HEB with an increasing sequence of T1. We can start with a small value of Z0, which is not necessarily larger than C. If Z0 is larger than C, the first course of SVRG HEB will achieve an epsilon optimal solution. We can also provide the same convergence results as SVRG HEB. We then consider the case of quadratic error bound. For this case, we may consider to start with a small value for C and then increase its value by a constant factor in order to increase the value of T1. But the challenge is that when we should increase the value of C. If we follow a similar procedure as SVRG HEBRS, we may obtain a worse iteration complexity. So we want to develop a certificate to check whether the value of C is really large enough for SVRG to decrease the objective value. Our motivation is that the property of proximal gradient update, that is this inequality. We can use the norm of the difference as a gauge for monitoring the decrease in the objective value and develop the certificate for searching the value of C. This is the details of the proposed algorithm. Step 8 to step 10 are the search steps for the searching the value of C. We can show that if CS is larger than C, the condition in step 8 will happen with a very small probability. We also provide the linear convergence for the adapted SVRG and the quadratic error bound. Thank you.